Right. What is the area of the region between those graphs from 0 to 3? So we're going to set up our integral 0 to 3. You need to know which one is above the other one because it's going to be upper minus lower. I would maybe either just draw a sketch off to the side or sort of use my imagination. This is a parabola that did what? So the parabola is up 1, and then the line is going to be like this. Are you seeing it? The parabola is above the line. Okay, so it's going to be this one minus this one. Basically, if you did it backwards, you would get what as an answer? You get a negative and you go, oh, whoops, it needs to be the other way. All right, so it's going to be the x squared plus 1 minus negative 2x. So it'll be plus 2x dx. It's not calculator, so you have to work it out by hand. We're going to do antiderivative, upper minus lower. It's your fundamental theorem of calculus. So what is your antiderivative for this thing here? 1/3. Yeah, 1/3 x cubed, good, plus x plus x squared, such that 0 to 3, basically just plug in 3 because 0 is going to make all those go away. 3 cubed. Good, 27, 1/3 of that, 9 plus 9 plus 9.
Plus 9.
Oh, 3. Okay, I was going to say, wait, I didn't think they all came out the same. Good, that one's 3 and then 9. Sorry. Dyslexia moment there. So 21. Cool. Write, but do not evaluate. Those are like my favorite instructions. Okay, just do nothing. Cool, can handle that. All right. Write, but do not evaluate an integral that will give you this area. So it will be from where to where. Look at your intersection points. So A to D, good job. And then it's upper minus lower. So which one is the upper graph? G of x, good, minus f of x dx. It's just areas. There's no squareds. There's no pi. It's like just the upper minus lower. So don't overthink that because it's going to be multiple choice and you know all the wrong choices are going to have all those like extra doodads in them. Okay? Let R be the region bounded by this graph, vertical line x equals 7 and the x-axis. We want an integral both ways. So one that would be a dx and one that would be a dy. Let's go ahead and take a look at this because it's not going to take that long to graph. Your x squared, your square root of x is going to look like this. And then your vertical line x equals 7 is going to look like this. And I'm just going to put a 7 there to show that that's 7. I don't feel like drawing all the little tick marks in there. Let's do dx first. That's for sure going to be the easier one. Your integral would go from where to where? Yeah, so 0 to 7. Upper minus lower. Well, the upper graph is square root of x. The lower one is 0. So it's just square root of x dx. Again, nothing squared. There's no pi. It's not revolution. It's just areas, upper minus lower. Now, if you go to do that sideways to make it dy, it's going to have to be right minus left going this way. So we are going to have to rearrange this equation. So what would you do to it to make it x equals instead of y equals? Yep, square it. So we're going to set this up for dy. I'm going to come back to the boundaries because they're actually a little bit tricky. Let's do right minus left. Which is your right graph? 7, good, minus y squared dy. Now your boundaries, it's not 0 to 7 because it has to be y values. So it's 0 to whatever this is on the y-axis. Do you see what I'm saying? Any thoughts on what that would be? It's square root of 7. If you plugged 7 into this graph, you get square root of 7, whatever that is. I don't know what square root of 7 is off the top of my head. Like 2 point something. It'll be multiple choice. Okay. What is the area bounded? Oh, they even say left and right. On the left by this thing and on the right by this thing, y 4 to 8. We actually don't even need a graph because they told us our y value boundaries These are both already x equals, and they told us which one was the right and which one was the left. So we can go ahead and set it up. We don't even need a picture because they told us everything that we need, which was actually kind of nice. So your boundaries will be 4 to 8, and it's right minus left. So it's going to be 3y minus 8, because it says that one's on the right, minus, now we've gone over this before, I would rewrite that a little bit of a different way. How can we put this so that it'll make like a little bit more sense? Yeah, good. I just feel, and then that's a personal preference. If you disagree, totally fine. I just feel like when you go to do the next step, it's nicer if you have a coefficient in there. This is going to be nasty with the fractions. Like the hardest part of this problem is going to be the fractions, not so much the calculus, all right? Because it's not calculator. Antiderivative. I'm asking you. Get 3/2 y squared, perfect. Good, and you said y, not x, which is perfect. Now this would be 1/3 y cubed, but there's already a 1/4 there, so 1/12 y cubed. And unfortunately, neither of the boundaries is 0. Womp womp. I feel like I am going to need a calculator here for this one because I threw an 8 in it. You guys understand that what I do is I take the test questions and I change some of the numbers in them. The numbers on your test would be smaller. Okay, so I may end up having to reach for a calculator here, but we'll see what happens. All right, plugging in 8. 8 squared. 64. We'll see how far we get. Divided by 2. 64 divided by 2. 32 times 3. Nice. Okay, good. You guys stuck with me there. Minus 64 minus, now I know that 8 cubed is 512, but that's only because I live in this room and do math problems. I don't really expect you to know that one, but it is 512 twelfths. Again, on your test, it'll be a smaller number that's like more reasonable. All right, minus, now we're going to do the lower boundary. 4 squared. 16, half of that, 8 times 3, 24, perfect. Minus 8 times 4 is 32. All right, 4 cubed, that's reasonable. I do expect you to know that one. That's 64 twelfths. I get that those reduce, but I just left them both twelfths because they're the same. All right, so let's see. 96 minus 64 is 32. Yeah, we're going to have to like battle through this here. I'm going to just distribute the negative. That's my personal preference. I just feel that I'm always scared I'm going to mess up a negative sign. So I just distribute the negatives. I won't conceal from you. I kind of hate this. Is this calculus? No. We're having to fight through all these numbers. But it is good for you because they'll do this to you on the AP exam. And you are allowed to feel frustrated. Your feelings are valid. And I'm on your side. Okay. 32 and 32 be 64. Minus 24 be 40. And then what? Again, it'll be smaller on your test. Negative 512 plus 64. That's 448 twelfths. And actually, I think, yeah, they leave it like that in the multiple choice. You don't have to get a common denominator. And again, the numbers will be smaller on your test. You guys hung in there with me through that. Oh, this one is calculator. See the little C I put next to it? So I'll get a calculator at some point here. From 0 to pi over 2, K is between 0. Basically, we're in the first quadrant is what that's saying. Do you remember some pre-calc? Quadrants and stuff? Okay. We've got y equals sine of x. From K to pi over 2, they're saying this is the answer, 0.3. What is the value of K? All right, let's set up our boundaries. It says from K to pi over 2. So it's going to look like this. And then what goes in there is sine x dx. And what they're saying is that that equals 0.3. So you kind of like are given the answer. You're missing a small piece of the question. I know you're like, is it cosine or is it negative cosine? Think about it for a second. When you do your antiderivative, negative cosine. I brought it up because it's hard. Equals 0.3. So we're going to do upper minus lower. Unit circle time. Where's pi over 2? Straight up. All right, that's the 0.01. Cosine is X, so that's perfect. Good job. 0 minus, now your lower boundary, if you plug in K, you're going to have negative cosine of K, whatever that is, we don't know what K is, equals 0.3. Here's where I'm going to pull up the calculator. First of all, what happens to those negatives? Yeah, they cancel. So I want cosine K equals 0.3. So let me share my screen. I need to be in radians. Let me just double check. Radians is the default, but I just always check. Okay, radian, because it'll be wrong if it's degrees. I'm going to type X. See how it won't give you a graph if it's K? All right, so I'm going to type X. And here I'm going to type Y equals 0.3, and I'm going to look where they intersect. The reason I picked that one instead of all of these other ones is it says we're in the first quadrant. It's going to be the first positive one. And that's your answer. 1.266. So we had to work out the problem a little bit by hand, and then I ended up reaching for the calculator. Good halfway point will be. We'll see when the bell rings here. Oh, another calculator one. What is the area enclosed by those two graphs? Well, I'm going to just type all this in. You ready? It's a calculator question, so let's just type it in. That means I need for you guys to watch, all right? So we're going to have y equals x to the third. Shutting the door pretty please. Someone let a wild animal loose out there. All right. So let's see. Let me zoom out here a little bit. So do you see how we have this area right here where my cursor is? I don't know if my cursor will show up on the recording, but do you see how there's this area? And then yes, do you see how there's also this area? So we want to go from the beginning, which is 0, all the way until the end, which is 6. So on your paper, you're going to write integral 0 to 6, and it doesn't matter which one's upper and which one's lower, because what are we going to put around it so that we get the whole everything? Yeah, absolute value. So I would do this one minus this one just because, I mean, it's not going to make a difference because we're absolute valuing it. Bless you. Total area. When it just says what is the area, it means the total area. I wish that they would throw the word total in there though, because I feel like that is an indication. They'll sometimes do that with absolute maximum. They'll just say, what is the maximum? And you have to know it means absolute and that you're going to do a candidates test.
That's what that means. It doesn't say.
Yeah, it just means the biggest one. Yeah, no, see, I'm glad that you brought that up because then we just had a conversation and now I clarified it for everybody. They do that sometimes and they'll do it a lot if it's a story problem. Like, give me a story idea. I don't know, like turtles. All right. What is the maximum number of turtles that did something? Do you know what I'm saying?
Yes.
Well, one problem one year was about fish, so you're not far off. If they just say, what is the biggest amount? They won't even use the word maximum sometimes. What is the most turtles? You have to know that means absolute maximum and that you're going to do a candidates test. Okay. I'm glad we talked about that because then I can clarify. So I'm going to just type this in. Integral 0 to 6. Absolute value. I got to go get that. Hold on. Absolute value to the third. What is it? Minus 8x squared. That'd be plus 12x, right? But I minus the 3x. There you go. 49.333. All right, that's it for areas. Now we're going on to our cross sections. Base of a solid is the region in the first quadrant bounded by x cubed and the x-axis. Can you envision that? Your wiggly graph? Okay. From 0 to 2. Each cross section is a semicircle perpendicular to the x-axis. So we know it's going to be dx. Go ahead and draw yourself a semicircle. The base of your shape is upper minus lower. The upper graph is like the only graph they gave you. The lower one is 0. So it's just x cubed, which is nice and simple. And now we're ready to set up an integral. So it's from where to where. They actually hand you that too. They sort of gave you everything that you need. Leave a big gap. Now what goes in there is the area of your shape. So how do you do the area of a semicircle? Perfect. 1/2 pi r squared. Now here's the most commonly missed thing is people take this x cubed and just put that right in there. That's the diameter. You need radius. So it's half of that. Do I have to actually work this out? Wait, say again. No, they do not. Okay. So here's what I would do. I would remove the pi. You can, again, this comes down to personal preference, how you want to deal with that. Now I'm going to do the coefficients. You have to take everything in these parentheses and square them. So 1/2 squared, a fourth, times the other 1/2 out there is an 1/8. Good. You guys came with me on that? Oh, good. Why is it x? Is that what you said back there? Why is it x to the 6th? I was looking for somebody to say that. I thought that's 3 times 2. Perfect. So now your antiderivative, I'm going to kind of bracket this off. You would want it to be 1/7 x to the 7th. There's already an 1/8 there, so good job. X to the 7th. 8 times 7 is 56. Such that 0 to 2. And then basically you just need to plug in 2. We're going to count on our fingers. Ready? You can keep doubling. 2, 4, 8, 16, 32, 64, 128. All right. All right, but that reduces, doesn't it?
They're both even.
I think they'll both divide by 4, right? If you divide by 4, this will be 32 pi over 14. Actually, yeah, then they'll divide again. What is that? 16 pi over 7? Thank you. Good deal. All right, these ones are both calculators, so we're just going to set it up and then type it in. All right. We want region in the first quadrant bounded by these graphs. Let's go ahead and just draw that really quick. This is a parabola. I only drew the part in the first quadrant because it said first quadrant. This is a line, so it's going to look like that. Get it together. All right, what is our shape? And we're perpendicular to what? They have to tell us those two things. Y-axis, so it's backwards, and square, which is kind of nice. That's usually, the easiest shape. So as soon as we realize it's dy, unfortunately, womp womp, you have to go and rearrange both of your equations. So how would you make this one x equals? Oh, actually, I don't usually bring this up unless somebody does. So when you square a root, it is plus and minus, but do you see how it's only the part in the first quadrant? So positive, okay? And then this one you would divide by 2. So the base of your shape is right minus left. Which one is the right one? Square root of 1 minus the left one, which is the line, 1/2 y. Then we're ready to set up an integral. We need y values. So it's going to be 0. Now I didn't put tick marks on here. Up to whatever y value that is. So we have to think about where these intersect, which would be 2, 4, right? Because 2 times 2 is 4 and 2 squared is 4. So their intersection is going to be at 2, 4. 2 squared is 4 and 2 times 2 is 4. I just thought about where they were equal. Or you could just be more particular than I was about graphing your I just kind of swooshed my graphs in there and was like, oh, I'll figure it out later. But yeah, or you could just set them equal to each other. But anyway, it's going to be 0 to 4. And then inside of there, you put the area of your shape. So how do you get the area of a square? Yeah, base times height, which would just be this stuff squared. And it's calculator, so I'm going to just put in and hope not mistype anything. All right. Where root, what, stop paying attention. We need to watch what's going on. Because if I type this wrong, the whole thing is wrong. Squared, the parenthesis, dy. 5, 3, 3, 3, 3, 3, 3. You don't like that answer? You would.
So when you're doing the right minus left, can you explain, I know you've done it before, but why the parabola is on the right?
I don't really have a good explanation for that. That's why I put the R and the L in there. This is the one that's on the right. And then that's the one that you kind of just look at which one is where. I'm sorry, I know that's a totally crap answer, but one's on the right and one's on the left, so I don't really have a better explanation. But that's why I put the R and the L. So do you see how this one is like the right one and then this one's the left one? All right, we'll do a couple more before we do the halfway break, right? Base of a solid, region in the first quadrant bounded by these graphs. Oh, and I was being silly about this too. Talking you through how I did that, like just by using my brain. It's a calculator question. So what's the other thing you could do? Type them in the calculator and click on the intersection. I'm being a dummy. All right, I'll do that with this one. Got region in the first quadrant bounded by that. Perpendicular to the y-axis again. What does that mean we're gonna have to do? Switch it or okay, so let's go ahead and do that. What would you do to start solving that? That is frustrating because it's all this algebra. All right, -4. Sorry, I should try and have a good attitude about it. I just feel like I want to test you guys on calculus, not algebra, but they're gonna do this to you on the AP exam. So now here's what I would do. I would deal with the negative first and just flip-flop everything and then deal with the fraction. Again, that boils down to personal preference. So to cancel out a 4/3, you would multiply by 3/4. So this would be -3/4 y plus 3/4 times 4 would just be 3. 4s are going to cancel. All right, that wasn't too bad. All right, what is our shape that we've got? All right, rectangle. The base of your shape is going to be right minus left. I'm going to go ahead and type in so we can get a visual here. I need to graph it by hand. I was being stupid in the last problem because we used the calculator for this one. Go home here. All right, so it's going to be right minus left. Oh, it's a triangle. So the right graph is the one that we were just looking at. The left graph would just be 0. It's just the axis. So just this -3/4 y plus 3. And then what's the height of it? They have to tell you in some capacity, like it has to be in there. Okay, so 3 times that. All right, and then we're ready to set this up. So I need y values for my boundaries. Let me just come right back over here to my calculator. It would be 0 to what? 4? You just put it in. And then how do you do the area of a rectangle? Yeah, base times height. So the easiest way to write that is to put that 3 in there and then this stuff squared so that you have it twice. Or you can write it 2 times if you want to. Like some people are a purist about it. Like, no, I must do base times height. Like if you are one of those people, that's totally fine. I don't care as long as you get a right answer. I'm good however you get a right answer. As long as it's not cheating, we're good. All right, watch me type this. Make sure I don't type it wrong. It'll look good. Squared. Oh, 26, the answer. You know why I came out with such a nice number? Is because the base is what? It's a right triangle, so it wasn't like a really awkward shape or anything. So it turned out, kind of nice. How many are on the next page? Let's try and do all of this next page and then we'll do our halfway break. See how long they take us. Are any of these calculator? The last one is. All right, these are your diff. Let R be the volume of the solid generated when this region and the horizontal line y equals 4 in the y-axis is revolved, revolution. Why I'm silly about that word is because it should jump out at you like, oh, we're spinning. Around the horizontal line y equals 4. All right, let's take a look at this. Oh, wait, did I skip that question? Oh, I didn't move my paper down the whole way. Oopsie, sorry, let me go back. Triangular region, oh, in the second quadrant, so I know this is going to be in quadrant 2. Vertices, the origin, -a, 0, and 0b. So this triangle is what they're talking about here. Write an integral expression. So we're not going to actually work it out. We can't because we don't know what a and b are. When this is revolved, revolution, around the x-axis. So it's going to be a dx. This will be your ghost shape down here. What would that look like three-dimensionally? Like if I turn it this way, do you see it? Use your imagination. What would it look like? Yeah, cone. Pyramid, something like that. Well, no, because a pyramid is like flat on each side. Cone, it's a cone. All right, like a funnel, except it's solid the entire way through. All right, so it's going to be pi r squared dx. Set it up blank. Yeah. Yeah. Okay, so what are your boundaries? You're going to go from where to where? -a to 0. Good job. And by the way, since it's multiple choice, if you figure out those boundaries, what can you start doing? Yeah, crossing your choices out. You can practically pick it based on that. All right, now your radius is going to be upper minus lower. So your upper graph is this line. We're going to have to write an equation for that. The lower one is the axis, which is 0. Do you guys remember good old y equals mx plus b? That's what we're going to do here. So what is your slope? You go up how much and over how much?
Up B.
Now the line is going upwards, so it's positive. You go up b over a. Okay, so it's b over ax plus your y-intercepts, which is b. And you don't have to do anything. Actually, you can't do anything with that because you don't have any numbers. So that's the answer. All right, this is the one I started doing, but I didn't move my paper up enough. All right, let's go ahead and draw a picture of this. We've got y equals x, which is just gonna look like that. Slope of 1. And then we've got y equals 4, which will look like that. And the y-axis. So we've got like this triangle in here. And again, personal preference, but I just erase like all the tails off of that so that I've got just that one shape that I want to look at. And what are we revolving around? They have to tell you that. Y equals 4. So it's going to be like this. It'll be another cone shape kind of thing. So is it dx or dy? I heard both. It's like you took the x-axis and just like moved it up a little bit. This is your axis of revolution. All right, so it is going to be dx. Set it up blank. Pi r squared dx. And inside, oh, first the boundaries. Sorry, it'll be from where to where? 0 to 4. And then it's upper minus lower. Now you're not going around the axes, so neither of them is 0. Which is your upper graph? 4, good, minus x. Is that it, or do we have to work this out? Did it say set up? But nope, we have to actually work it out. I know, or I'll give you a break after this one then. You're gonna have to do a little bit of algebra. Leave this alone for a second. You have to work out 4 minus x squared. If you need to off to the side, this is what that means. Squared means you're multiplying it by itself. So you're just going to have to distribute everything to each other. So let's see what you got. 4 times 4. All right, 16. Minus 4x and minus 4x. It's 8x. Negative x times negative x plus x squared. Good. Your algebra skills are good. Now the calculus. Antiderivative would be 16x minus 4x squared. Oh, yeah, I know. Plus 1/3 x cubed. Such that 0 to 4. And you really just need to plug in 4 because the rest of it's going to be 0. So 16 times 4. is 64. 4 squared is 16 times 4 is 64 plus, what is this part going to give you? If you plug 4 into that. Yeah, a third of 64 thirds. So these cancel and you get 64 pi thirds, 64 pi over 3. Okay, number 12. What is the volume of the solid generated region in first quadrant bounded by? Okay, we need to know what e to the x looks like. I'll even take a hand motion or like just act it out or like, yep, swoop. Okay, like this. Do. And the vertical line, x equals ln 5. So whatever that is.
How did you know?
It just says vertical. So also x equals would be vertical, y equals would be horizontal. So this is your shape, and if you want to erase all the little tails around it, then you can do that. And they have to tell us what our axis of revolution is. So what are we revolving around? Yes, the x-axis. So it's dx. The x-axis is the easiest one because it's dx, and one of your, graphs is going to be 0. So if you want to draw yourself a ghost shape down here, it's going to look like this. It would look like what? 3-dimensionally, what would this look like? I was going to say a tree stump. No, that's not wrong either. You guys were way more creative than me. I thought tree stump. Anvil is good. Nuclear reactor. All right. So pi r squared dx. What are your boundaries? From where to where? Yeah, 0 to ln 5. Again, whatever that is. And then in here, it's upper graph minus lower graph, which would be e to the x minus 0, which is just going to be e to the x. When you go around the axis, one of your graphs is 0. I'm going to real quick clean that up a little bit. If you have e to the x squared, it is e to the 2x. Did everyone come with me there? E to the x squared, you're multiplying these together. A power to a power means you multiply, so it's 2x. Now, I'm going to talk you through this too, because I don't want you to have to write out every last little thing. That would be a u substitution where u equals 2x. Just listen to me. U equals 2x. Coming with me there? Mm-hmm. What adjustment number would you need, therefore? A what? A 1/2. Do you see what I'm saying? We're not going to write out all the u equals everything. We're just going to slap a 1/2 in front of it and be done. Okay, if it's real simple, that's what I want you to do. For example, if this was 3x, you would just put a 1/3 in front of it and move on with your life. Okay, thank you for heads nodding. I got you all there. All right, so it's going to be pi times 1/2 e to the 2x such that blah, blah, blah. E is its own derivative, so it's its own antiderivative. It looks like I didn't do anything there, but I did an antiderivative. It just didn't change. Remember that meme that's like, I can change it? Anyway, we're going to do upper minus lower. I'm just going to kind of leave the pi out front for a second. I usually do that. You can sort of ignore pi until the end. Just all the answers will have a pi. Basically, if it's multiple choice, you can do the problem without pi, and then just all the choices will have pi in them. All right, so upper minus lower. Here's where I also have to go through and explain a logarithmic thing, which everyone always stares at me and goes, where on earth did that come from? If you take ln of 5 and plug it in there, just listen to me while I explain this. You don't have to write it all down. You see how that would be 2 ln 5? You're allowed to take the 2 and make it the exponent again. Do you remember that? It happened last year in pre-calc. And when I teach it in pre-calc, I always say this is the thing when I get to it in AP Calculus, everyone just stares at me. But anyway, it would be ln of what? Good, thank you, 25. 5 squared is 25. Yeah. If you plug in 0, you're not going to get 0. You have to be careful with that sometimes. Like and I guarantee one of the wrong answers is if you just ignored 0. E to the 0 is not 0. It is 1 times a half is a half. Oh, I'm so sorry. Thank you. I forgot to write the E. I apologize. I'm so sorry. Copy error. I did the whole logarithmic thing and I forgot to leave the, actually, that's good that the E is there though, because then what's going to happen? Yeah, they cancel. So you have 25 halves minus 1 half be 24 halves, which is 12. So 12 pi. This one is calculator, so I'm going to just type it in so we can look at it. But what does your sine graph look like? Good, I'll take that. It is a wave. Actually just started graphing sine today. See it? Cool. All right, so we want that in the first quadrant. So that's going to just be this first part. Do you see this here? Okay. We want to spin that around x-axis. So just to like give you a visual, this is the part of the graph that we're looking at, and we're going to spin it around the x-axis. So it's going to look like a Hershey kiss or something.
That's like a vase.
Or a vase that you can't put anything in because it's solid the whole way through. So pi r squared dx we need to find our boundaries. So I'm going to go back to my graph. Where is this hitting the x-axis? Yeah, see that 3 pi over 2? Our boundaries are 0 to 3 pi over 2. And this is your radius, which is just going to be like that equation. Let me go ahead and type this in. I want you to watch, make sure I don't mess it up. Pi integral 0 to 3 pi over 2 parenthesis, another parenthesis. 1 sine x plus parenthesis squared parenthesis x 2, 8.489. Well, actually, during the break, I just made a snap decision that I'm getting rid of one of these. So, all right, this one is calculator. We want this region and the lines x equals 0 and y equals 3 revolved around the y-axis. It's calculator, so I'm going to go ahead and just type it in so we can get a visual here, see what it looks like, and get our boundaries. X equals square root y plus 1. All right, so something like that. What were the other graphs? X equals 0, that's just your y-axis, and y equals 3. Here, I'll just type them both in. You can see it. Okay. So this, what are we spinning around? Y-axis. All right, so it's going to be pi r squared dy. Just go ahead and set it up blank on your paper. Pi r squared dy. Boundaries are going to be y values. So look at your y-axis. That's going to be from where to where? Yep, -1 to 3. And it's right graph minus left graph. So the right graph is that square root of y plus 1. And your left graph is the axis, which is 0. And then I'm going to just put that in the calculator. Do you see how the square root and the squared would cancel? When I go to type it in, I'm not going to actually type the whole square root because that's annoying. All right, -1, 3 plus 1, 1. And that rain is coming down. All right, 25.132. All right, now we're on to the washers or the donut ones. Let R be the region enclosed by sine of x. So you've got that wave from 0 to pi. Oh, write an integral expression. That means, do we have to work it out? No, just set it up. We want to spin around the horizontal line y equals -2. I do want to kind of get a visual for this one though. Sine of x, it's not transformed at all, so where does it start?
Here.
Good. I'm gonna make each of these be pi over 2. It's gonna go up, come back down, go down, come back up. This is what we're doing in pre-calc right now. I actually really love that unit, graphing the trig functions, like one of my favorite units. All right, so we want from 0 to pi, which is just this part that looks kind of like a semicircle, but it's not exactly a semicircle. And what do we want to spin around? What is our revolution here? Y equals -2. So is it going to be dx or dy? Well, it's like you took which axis and scooched it? X. So it's going to be dx. You're going to need to set it up blank first. And there is going to be a big old hole in the middle. So r squared minus r squared dx. What are your boundaries going to be?
0.
0 to pi? And I will attempt to draw this ghost shape. It's going to be all the way down here. So your outside circle goes like all the way to the edges, and your inside circle is this middle part. So I guess it would be like, do you see? Like it would be like this, like but then like a big hole through the middle. I don't know. I don't even know what that would. An inner tube? It would be like an inner tube. Do you see it? Or a what? Or yeah, like a necklace. So the axis of revolution was at -2. So when I did my reflection, it reflects all the way down to here. It's like 2 units away. Do you see what I'm saying? Like that.
Yeah.
And actually here, we can do that part first. What is your inside radius? That's how far? From here to the axis of revolution. Or just 2. If you put -2, that, well, it's multiple choice, so you won't be able to do that. But when you square something, it would turn positive, so you can actually still get the right answer anyway. All right, and then the other one, upper minus lower. Your upper graph is sine of x, and your lower graph is -2. So it's sine of x minus -2 should be +2. And that's the answer because it said to just set it up. Now I made a last minute decision. I'm going to get rid of number 16. Because this is, I realized I gave this test last year and everybody finished it, but that's just a little bit too long. So I'm going to get rid of that one. All right, are we doing okay on time? Yeah, we're good. I should still finish with you guys to have some time to work on your multiple choice. All right, region in the first quadrant, bounded above by 2x and below by x squared. I learned my lesson from just drawing them in before, so I'll be really specific about it. Your y equals 2x. You're going to go through the origin and have a slope of 2. And then your y equals x squared is your regular old parabola. So they intersect at 2, 4. When I did that on the other problem, I just sort of drew it in and expected you guys to know that, and that was bad of me. I should have talked you through it, but that's how those get grabbed. All right, what are we spinning that around? What is our axis of revolution? All right, now that's x equals -4. That's going to be all the way over here. So is it dx or dy? Well, which axis is it like you scooched over? Y, good. So it's going to be pi r squared minus r squared dy. Oh, and we don't have to write or work this one out either because it just says write an integral expression. So we don't have to actually work it out. Your boundaries need to be y values. So look at your y-axis. It'll be where to where? Yeah, 0 to 4. And again, it's multiple choice. So you can start narrowing down your choices as soon as you realize what the boundaries are. I will attempt to draw this ghost shape, but it's going to be all the way over here. If you don't want to, that's fine. I'll just try to help you to see it. I don't even know what this would be like.
Like you know when they take the dough to make a bagel, but they keep going.
Okay, so like a really large bagel.
That's dough. It's not
Sure. I don't know. I'm not seeing anything that reminds me of.
happy.
Like, oh, okay. I guess I get. I'm glad you're envisioning it. It's round anyway. As long as you understand it's round, then we're good. All right, so it's going to be right minus left. Oh, we're going to need to rearrange our equations to make them x equals, since it's a dy problem. So this would be 1/2 y. And then this one over here would be what? Yeah, square root. No. Yes, square root of y. Sorry. Brain did something funny there. So when you do right minus left, watch, I'll just point to it. For the outer one, which is your right graph? Yeah, the parabola, so this one. And your left graph is -4. So it's going to be square root of y minus -4, which is +4. It's right minus left. And when you do this one, it's going to be the same thing, except now you're using the line. It's right minus left. So it'll be 1/2 y minus -4, which will be +4. All right, these are for your response. Some of this is review. I did that on purpose because I get these volume questions are difficult, and I was trying to give you something that was a little bit different. Like, hey, if this unit isn't like your cup of tea, then, I'm giving you something else that's on there that you can kind of focus on. So let H be this function, find H prime of 5. You're going to find H prime, you're going to plug in 5. Welcome back to derivatives. So what rule do you need? Chain rule. Good job. This is literally just your chain. Remember that bubble sheet that we did a million years ago? All the derivatives on? Little bubbles. All right. This is literally your chain rule. It'll be F. What? F prime of G of X. Good. Perfect. And that is usually worth 2 points all by itself. It is that important. Then you're going to plug in 5, and we're going to use this handy table here. So you're going to have to watch me point to stuff because I don't have a better explanation than, hey, look, there it is. All right. So we're going to start with G of 5. What is G of 5? Link up G and 5. 8. Then you have to do F prime of 8. Okay, so F prime of 8. Good. 3. That first part is 3. Little chain rule dot. And then you're doing, still plugging in 5. G prime of 5 is -3. So the first part is knowing the chain rule. The second part is using a table. All right, let K be a function such that it equals this monstrosity. Is K concave up or concave down? Which derivative do you need for concavity? Second derivative, and they gave you first derivative. So we just need to, get to the next one to do our concavity. This is going to involve a chain rule and a product rule. How does product rule start? The first thing, all right, f of x cubed. The first thing times derivative of the second thing. Good job. Plus, yeah, and if you want to put it in that order, that's totally cool. I always do the second thing and then derivative of the first. That's where the chain rule comes in. You're going to bring the 3 down, drops to a 2, and then you chain on, the derivative of what's inside. I can't remember everything in the world, but if instead of a cubed that was a squared, it throws everybody off when they bring the 2 down, and then that drops to a 1. So just be careful with that because I think it might be like that. Okay. What are we plugging into this? 1. Good job. F of 1 from the table there. 9 cubed, whatever that is. Yeah. All right. G prime of 1 is 3. I agree. Plus G of 1, 4 times 3. F of 1 is 9 squared. And then F prime of 1 is 2. I don't really care what that is. All I need to know is whether it's positive or negative. Yeah, there are no negative numbers in there, so that's positive. Your sentence is going to start K is or K has. K is concave up at x equals 1 because What's our reason? You say, we'll give it to you. K prime prime is positive there. Good job. Oh, that was quick. Was that good news? All right, let M be this function. Find M of 8. Okay, well, we're going to plug 8 in. 4 times 8 squared, whatever that is. You can work that out if you want, but it's free response, so you don't have to. Plus integral from 0 to 8 of all of that. This is your fundamental theorem of calculus. If this is G prime and you do an antiderivative, that takes you backwards to just G. And then it's upper minus lower, which you're going to get from the table. If you ever find yourself trying to look up a number that's not on the table, you've done goofed somewhere. Like they have to, like, do you see how the only X numbers are 0, 1, 5, and 8? So if you find yourself trying to do f of 3 and it's not on there, then you messed up somewhere in the problem because they can't give that to you. All right, so G of 8. 7, good job. Minus G of 0, negative 2. Yes, please do not. Thank you for bringing that up. All right, is that function that we just looked at increasing, decreasing, or neither at 8? Now, concavity was the second derivative. Increasing and decreasing is first. Okay, so we're going to find M prime. We're going to plug in whatever it was, 8, and we're going to see if that comes out to be positive or negative. So what is your derivative of 4x squared? 8x, good. Plus integral and derivative cancel, and you just get the stuff inside. So derivative of this was 8x. Derivative, remember when we just took the x and plugged it in? It's all that is. Okay, now we're going to plug in 8. 8 times 8 is 64. From your table, G prime of 8 is 2. So your sentence is going to start M is or M has. This one is M is, what do you think? Yes, increasing at x equals 8 because who's your source? M prime is positive there. All right, go ahead and flip over. We'll do this last one. It's a calculator one, so it shouldn't be too terrible. Oh, you know what? I need a, can I borrow a yellow? Okay. All right, let R and S be defined over here with these two graphs. Let's first figure out which one is which. So the 5 minus 2x squared, that should be an upside down parabola. So that's this one is the 5 minus 2x squared, if you want to like label. And then the exponential swoopy thing, this one is the 3 to the x. I don't know really where to write that down here, 3 to the x. But anyway, the upper one is the parabola, the lower one is the exponential. R is the region in the first and second quadrants. So this entire thing, I don't know how well this is going to show up. Can you see that at all? Sort of. This whole thing is R. It's okay. Better than nothing. All right, and then it says S is the region in the what? Make sure you read carefully. S is where? First quadrant. So S is just this part. That is pink. That is yellow and pink. So do you see how R is like that whole everything? S is just in the first quadrant. So find the area of S. We're going to just set it up and put it in the calculator. But of course, since this is free response, it's not going to be real simple. You are going to have to split your integrals here, which is at what number? Where are we going to have to split this? At 1. That is a 1. Okay, so we're going to have integral from 0 to 1. Which graph are you underneath for just this part. Yeah, that's 3 to the x dx. So that would give this area. And then we have to do plus integral from 1 to whatever that is. I'm going to need the calculator, so I'm going to just hold off on that for a second. And we're underneath this graph, which is the 5 minus 2x squared. So what I'm going to do is open up the calculator and type both of these in. All right, so there's both of them. Now I need this point right here. Do you see where I'm clicking? Right there. So that's the other boundary, 1.58114. And then I would like for you guys to watch me type this, make sure I don't mess anything up. If I type it wrong, it's wrong. I can't even type int. All right, 0 to 1, here I'm going to type it right here. 3 to the x dx plus int 1 to the power 1.58114. There we go. 2.757. All right, did you guys all understand why we split it into two? Like how it splits right there. Okay. Find the volume of the solid generated when R is rotated around the horizontal line y equals -3. I will attempt to draw this in, but it's not going to look super pretty. Y equals -3 would be all the way down here. Y equals -3. And you're taking this R and spinning it around. It would be like, I don't know. I don't even know that I want to draw that the whole rest of the way. Do you get what I'm saying? Like my ghost shape would be all the way down here. Okay. Is it discs or is it washers? It's washers. Do you see how there's a hole in between? And then is it dx or dy? Well, it's like you took which axis and x. Okay. So set it up blank. It'll look like that. So let me go to the calculator and we'll get our boundaries. We want to go from here, which is -1.55214. I know that the decimal is awful, but do you see that I just clicked on it? Oh, that is. And then to this one, which is nice, it's 1. And then it's going to be bigger radius minus smaller radius. So let me come back over here. Which is the further away one? That 5 minus 2x squared minus -3. Okay, so it's going to be 5 minus 2x squared minus -3, which would be +3. Good. And then the same exact thing is going to happen in this one. You want the closer one, which is 3 to the x minus -3, which would be +3. Do I have to actually type that in, or is it set it up? Okay, fine. Fine, sure, I can do that. That's fine. Oh, wait, why did I just do that? I didn't do that. All right, if I'm going to do this, you have to watch. Make sure I don't type it wrong. -1.55214 to 1 parenthesis 3 parenthesis squared. Thanks. Minus parenthesis 3 close parenthesis squared close parenthesis dx 46.140. I do like to truncate. The only time you can't is on Delta Math because they round and it'll mark it wrong if not. All right, one. Region in R is the base of a solid. Cross sections. Oh, perpendicular to the x-axis. That means it's dx. Isosceles. What does that mean? Two sides the same. Right triangle. One leg is across the base. So it's going to look like that, which is great because the base and the height are same thing. Did it say R or S? R. So you want upper graph minus lower graph. So that would be which one minus which one? Yep, 5 minus 2x squared minus 3 to the x. So your boundaries are going to be the same as they were in this one. I already found them, so I'm not going to go back to the calculator again, but it would be the same thing. Inside of there, you put the area of your shape. So area of a triangle. Yep, 1/2 base times height. Now you can write the same thing twice if you want, or you can just put squared. Do I have to actually find it or just write a, thank goodness. Yeah, it's isosceles, so we kind of lucked out there. These are the same. You can write that expression twice, but it's just easier to write squared. But it's not wrong to write. Some people do like to write it twice, so. Oh, no. Well, I mean, height, altitude, those are interchangeable words. You can do it that way.